Project 4 is dealing with a recursive way of thinking through geometric sequences, which, again, I'm sorry these are so complicated to write down and process through without actual numbers. Don't let this be confusing. This is already how you think. If I say start with the number 3 and double it 6 times, could you do that? Sure. 3 doubled is 6. So 3, 6, doubled is 12, 24, was that 48, for 96. That thinking is recursive. You didn't start with the first one and try to figure out how to jump to the third one. You didn't start with the first one and figure out how to jump to the fourth one. First one, jump to the fifth one, or jump to the sixth one. That's silly. You just built the sequence as you went. And if I say, why don't you start with 3 and double repeatedly, can you tell me what the 8th term would be? Many of you would just sit there and think through that recursively, especially if you had a calculator. You're not going to go through this process. You're not going to say, oh, I know the first one. I know that I need to take doubling, that's a 2, right? You want the 8th term, 8 minus 1, 2 to the 7th time. No, you're just going to sit there and double 3 a whole bunch of times. And that's great. That is a recursive level of thinking. Now, if I ask for the 80th term, there's no way that you're going to double 3 80 times. You will then use that recursive form. Sorry, you will then use that explicit form to say, oh, he wanted the 80th term. That's going to be 3 times 2 raised to the 79th. That's a huge, huge number. Maybe too big for the calculator to hold nicely. So you wouldn't think through that recursively, but you could if given enough time. All right, so that is the essence of section 4. The rest of it is practical questions. Some of those were kind of ugly questions, right? But the pan flute, and I tried to make some nice, easy questions that worked out without a bunch of decimals. It was difficult to do. Now, I really, really need you to think hard through these number 3, especially this one where it bounces. It goes down, up, down, up, down. There actually is twice as many numbers there as you see. But if it rebounds 0.7 its previous height, if you drop it from 10 feet, it goes down 10 feet. And then it bounces up whatever 0.7 times 10 is. That's 7 feet. So it goes down 10, up 7, down 7. How far will it bounce up again? Whatever 7 times 0.7 is. That's 4.9. So it goes down 10, up 7, down 7, up 4.9, down 4.9. And we see that we've got this, oh rats, and I missed that bounce of 7 and 7. So there's a 10 and then a 7 plus 7 plus 4.9 plus 4.9 plus 3.43 plus 3.43, etc. all the way down through, and we end up with our number. So wow, I missed that bounce number 1 of 7. My apologies for that. With that missing of the 7. But that's the process that we can go through, and it is a challenge to keep all these things straight. So I'll have to fix that typo as well. Maybe send that out as an email to you. So watch that process as you go, and hopefully you caught that I missed the 7 in there. So bounce number 2, 3, 4, 5. It would mean that you would skip out on those 2 and add a 7 plus a 7 to get your final answer. The depreciation of the tractor, that's a very practical type of thing where we're multiplying repeatedly by 85%. Why 85? Because we're losing 15%. And if we're losing 15%, we're keeping 85% raised to the n for each 1 year that goes by. Why isn't it n minus 1? Because this is the value after 0 years have passed. So after each 1 year that goes by, we lose that 15%, keeping the 85%. So we have to do some thinking through on these, which I think that you can do pretty well. All right, so that is section 4. I will see you at section 5.